Without burning the daylight, I would like to request our Honorable Chief Guest to enlighten us with his informative speech. Honorable Chief Guest, sir, please. और ये चलाने के लिए आ जाओ.
This okay.
Pointer,
Okay.
yeah,
This.
pointer.
And then
Yeah, this one.
this. This.
Yeah.
Okay. Okay.
And
Yeah. That's
just touch this one.
Okay.
It's your.
Okay.
उधर की लाइट्स ऑफ कर दी.
Okay. Thank you very much. Namaskar. हमने सोचा था कि हम हिंदी में बोलेगा, बट हमारा नॉलेज जो है बहुत दिन हो गया है. एज यू अंडरस्टैंड, आई हैव बीन इन स्वीडन फॉर 48 years, so it has been a long time. So I think that it's better that I don't speak in Hindi because you won't understand anything. So I apologize for that, and thank you very much for all the fantastic words. And I really feel moved, because I think I feel also a great honor to be here. And as you mentioned, I mean, in our first presentation, you mentioned about the Agra University, but actually it is Bareilly College. I did my MSc here, but at that time it was only Agra University. So therefore, nobody understands Bareilly College. So you have to always refer to Agra University. So really, I'm very grateful and thankful to be here, and also the honor and the welcome that you presented to my family, because my daughter, she is coming from New York. She's working for UNO with child health and women power, and she is actually made her research in Udaipur with the ladies' health, I mean women health, that has been the main focus. And my son-in-law, he's working in, one of the best universities, that's Harvard University, mainly with the resistant bacteria, and that is the biggest issue now. So so I'm really very grateful that my daughter has picked up at least, because she studied biomedicine, and then she, not exactly the organic chemistry or polymer chemistry. I tried to influence her, but she picked up at least chemistry is there, some sort of relation is there. So it's really, thank you very much for the great opportunity that you gave me to come here. And as you know, I come from Sweden, and today is a very important day in Sweden, because today they will be giving away the Nobel Prize. And with the Nobel Prize, they have in the morning, they have this session for this giving away the Nobel Prize, and then in the evening they have big dinner. So I don't know how much you people follow the Nobel Prize. So now today, this week, whole week, Sweden is full of all Nobel laureates. So I don't know, since you're chemistry students, so the Nobel Prize in chemistry this year went to the 3 scientists who has discovered lithium-ion batteries. And that you can know, because without those type of batteries, we would not have been using our mobile telephone and all the things, because now you see that we don't talk personally. Instead, we try to communicate through mobile phones. So if we didn't have such type of lithium-ion batteries, so we couldn't have done that. So I think that is really a good, very interesting day today, because we have whole day, we have ceremonies and all that. So I feel especially, nice to be here in my old college and to see how the people, how you're working and how the things are going on. So I'm not going to be very deep in my lecture. What I will try to do, I will try to present a rendezvous about the materials, polymers. And as you know, I have been working for a very long time. So it happens that if you are working for a long period, if you're working with good science, then the results automatically become good. So I have been able to, influence something, and also I have been able to discover quite a lot. And therefore, I thought that it is very important to have some sort of provocative topic. Therefore, I put together today why polymers are outstanding materials. Because you are young people, you are young scientists. My mission is that more of you should pick up polymer chemistry or polymer technology as your main curriculum, because that has a tremendous possibility. So I shall try to give a little bit overview about why polymers are so important.
बेटे
So,
आप लोग बैठ जाइए
so the main topics that I will be talking today, I will try to present what I'm working with. That is a PP polymer. I don't know how many people are familiar with the polymers, so I will try to also talk about what are polymers and why polymers are so interesting materials. And since I don't know, because how your studies are organized here, but at least from my time, I knew that we had organic chemistry, we have inorganic chemistry, we have physical chemistry. So therefore, I picked up that what type of basic knowledge you need or required for such type of polymer materials. And of course, I mean, as you have with all technologies, so you have a lot of plus and minuses. So I will try to also summarize what are the main challenges and what are the opportunities with polymer materials. And there I have tried to focus a little bit on how India can contribute to that. Because I know that we have limited resources, but the best thing is that we have very many persons, people, and they are very ambitious people. They like to study, but the thing is that since it's so many students, so it is very difficult to keep the quality of the studies. So I will try to summarize in what type of studies, chemistry studies, may be applied for the polymer science. And then I will try to make some concluding remarks. So that is the main topics I'll be discussing today. So before I start, so PP Polymer, we are working with the industrial research company, and because now everybody is talking about we need to have a sustainable society, and sustainable society means that we need to think about how we use our resources, and once you have used those resources, when the life is over of those materials, how we take care of that. So what we are talking about, we are talking about some sort of circular economy. So we have been working since it was mentioned that I worked before I started with this company. So 11 years I worked with the industry, and there we found that, chemistry, you can do a lot of things with chemistry. And since chemistry is, if you don't use in a proper way, that can be very dangerous because they are chemicals. So when I was working with the industries, there I found that we have lot of things that we can do in a other way, different way, in order to make the environment safe and also safety for the people, because work safety is also important. So we established, after 11 years, we established this company in 1805 with the aim that we shall try to develop systems that are mainly environmental friendly and also maybe sustainable for the society. But at that time of at that period, nobody was talking about, sustainability or renewable resources and all that, which are the modern, phrases that has been used in our society. So as you heard earlier, so I did my MSc from here in 1967. It's a long time back. So I still have not come into the prehistoric people, but some historical people, because 52 years is a long time, and as I heard, that it has become a big change in the organization that you have today, and that in my time, because we have a very small, facilities and all that. So it will be great that to see how the department looks like. So that is a great honor for me to get this opportunity. And also, I will mention that we had a fantastic possibility after did my PhD, not PhD, but I'm an MSc. So I got the opportunity to work with synthetic and chemicals. And synthetics and chemicals, that was the first company that started manufacturing synthetic rubber that we use in tires and all that. Uh, First, based on the technology that was for Firestone in USA. And if I look back now, what is happening? So we started this company because we had resources for alcohol, and alcohol that was getting from molasses, and molasses that you get from sugar industry. So that means that from alcohol they made butadiene, and then also from benzene they made styrene, and then suddenly you made the whole rubber. So I should say that Bareilly or India has been very, very advanced in thinking, because they started already thinking about renewable resources. But unfortunately, when I come from Delhi, we took the train. So I always try to look into the old synthetic and chemicals, and that has become a monument, because it's really pity that they have closed down the factory, because the advantage of having such a factory is that provides you, all the young students, it's a teaching, because you learn, because when you learn a lot of things theoretically, then you need to have some place where you can make practice. So synthetic and chemicals, that is a very good school for getting into the polymer business or polymer science. And that brought me, because I worked there for 4 years, there I was working with the research and development, and they raised a lot of questions. What are the materials? How you can do that? And that created the interest to find out how I should learn more, because I have always been interested in learning things. The only curriculum that they had, that was at that time Kharagpur, IIT Kharagpur, because nobody was working in the field of rubber, and also at that time polymers, nobody talked about that. So I think I feel really very sorry when I pass through that company, because we have a monument that would have been possible to give a lot of facilities to the new young students as a school, and also it would have fitted very well to the modern society, where we are trying to make things from renewable resources. So that's just a short story, and then I went to Sweden to just find out what is about polymers, and I got a possibility to start my research. So I did my PhD in 1975, and then it is usually that when you work for a long time, and if you have passion for the subject, then you happen to find something. So in 1979 I become docent. I think that is somewhere like DSc. I don't know, that doesn't exist here in nowadays. But India, they had DSc, so 79, and that allows you to make as a academic, because that allows you some sort of permission to do few things on the academic side, and otherwise you cannot do that. Then I started working in the industry. I worked for 10 years, and then wrote a few books in coatings. that was published by John Wiley, both 95, 85, and 87, that you heard about. So that's just a story about how we started this PP polymer and how this PP polymer, that is mainly working with the industrial research, but where we are trying to implement the theoretical knowledge to practical, applications. So what we can say, if we look about, since I want to try to just to give you a rendezvous about polymers, so what are polymers? It's usually a Greek word that is poly means many, mers, that is molecules. So what we do, we put together a lot of molecules. I mean, you can make a similarity with, for example, if you join a lot of peoples. So if you join a lot of peoples, you understand that becomes strong. So if it's just one single person, so he or she is not strong. So if you join them together, then what you can do, you can get a very big, strong, power. And that is what we do. So since small molecules, they don't have good properties, so what we try to do, we join them together to get these fantastic properties. And also, as you can understand, that when we join the hands of many peoples, if we include different tribes, different, multicultural peoples, that makes that you make a very multicultural properties. So here you can see how the polymers, importance of polymers, that we try to combine lot of different molecules to get different type of properties. Also scientifically we say macromolecules. So macromolecules is big molecules, but I will prefer to use polymers because a lot of units are involved. Because when we say macromolecules, they are bulky. We see a lot of bulky people now, so we don't want to do that. So instead we try to join lot of hands and we can create power. So that is what we want to do. So that explains, for example, when we join a lot of people, molecules or people, so we can have long chains, we can join them linearly, we can then join them branch, and that means that you have a big possibility to create materials with different properties. And also, as I say, that you can join people with the same community, same tribe. You can, that we call, if we join the same molecules, then we call homopolymer. If we join different types of people, then we, different type of molecules, then we can make copolymers. So, you see that it is an endless of possibilities. So what we see here, in every specific type, when you make these molecules, so you need a very special knowledge of chemistry, you need very special techniques, and that gives you again possibilities. Because what we want to get into a science which gives you possibilities. Otherwise, as you say, that if you do the things in the same way, you will get the same results. But here you can see you have a lot of different possibilities, and if you combine that, then you can get different results. So what we can see, that since we have so big possibilities, so we can say that properties that when we combine these molecules in different way, in different stereospecific forms, conformations, so we suddenly get materials with lot of different structures. And that means when we have different structures, we are going to have different properties. So when we have such a different materials, that also opens a new science. That means that we need to characterize these materials. So as a chemist, you synthesize a lot of molecules, and then the next challenge is that we have to characterize them, and just to find that molecule has become that we want. So that means we need to have lot of different characterization techniques, different type of analysis techniques, and that makes still more complex. So I'm just trying to give you some idea about the possibilities, because I'm not going into how we do that, because that would be too specific. So what I'm trying to present here, just to wake up and see that you are in a world of polymers where you have just possibilities. Whatever you do, the only thing that you have to practice good science in a good way, and you have to understand why you are doing that. Purpose is very important. So you see, it's fantastic. Of course, I am a passionate, so I'm a little bit partial in this aspect. But what I try to communicate to my young generation, that is fantastic. Don't miss this chance. The only thing is that we have to find proper, base, proper things to start with. So if I just go ahead with the next, why polymers are so interesting materials. They are very light, because weight, we see that if you compare with steel, aluminum is lighter than steel, but polymer is very light. And that means if you, for example, make all the vehicles that you make, we are talking about, energy savings. So if you have light materials, so you already have very much possibility to save energy. And also, they do not corrode. So that means we have a big problem with the corrosion. Okay, we use a lot of steel. In India, we use a lot of concrete for building our houses. And that means that we have to renovate them every few years. And whenever you renovate, so you need still more materials. And that materials disappear somewhere, because that also consumes resources, and that also you have to replace it. So the advantage of polymers is that they do not corrode. So that means that they have rather long life. And if we think about the sustainable society, then we have to see how much such type of materials make impact on the environment. So if you have a material which has a very long life, that means that it is going to have less impact on the environment. So that means it is much more, sustainable for the society. And also, what we see that we are trying to rationalize our production. We need to have very short, time. When you produce a product, it should go very fast. It should be in the line and all that. And that has very good advantage with polymeric materials, that they have very short production times. And also that means that we can produce in large series, for example, in the cars, all the vehicles and electronics. So we need large amounts. It should go very quickly. And also the interesting part, as I mentioned, that we can make this tailor-made depending on the properties, on the end properties. So we can select a lot of materials depending on what we want. So suddenly you can see what are the big advantage of polymers. And when you make this list, so then I think if I ask you what you will select, of course, if I'm not here, of course now you'll say that it's polymers. But if you just, in a rational way, if you think, the ultimate, alternative will be polymeric materials. So you see that it's a great opportunity. You have fantastic materials that you can use for your, all the different demands that society needs for the modern society. If we go further, we can classify these materials as thermoplastic and thermosetting. That means that thermoplastic, when we say that it is, depending on the temperature, because if you increase the temperature, it becomes moldable, flexible. And when we say thermosetting, you don't have any influence of the temperature. So that means if you, for example, have a product that you need to use that has to stand high temperatures, so then you don't go for thermoplastic. So you select thermosetting materials. So here also we have lot of different ranges of materials. And if we go further, so we can classify these thermoplastic materials into three different categories. That is commodity plastics, that is what we use, for example, in buckets, in all the household things and all that, because they are cheap and they are being used in large amounts. So that is what we call commodity plastics. Then we have engineering plastics, that is vehicles, electronic goods, because they have, you increase the demand or the requirement, and that is also a little bit more expensive. And then we have high performance plastics, and that is very expensive, that needs very high temperature and everything. Yeah, it's okay. It's okay. So you can see that we have different categories depending on the price, different with performance, and also, as I mentioned, that we have a big requirement for it should be produced very quickly in a different way. So we have a lot of different production methods. For example, when we take injection molding, blow molding, extrusion, rotation molding, SMC and DMC, that is, then we are talking about SMC and DMC, then we are talking about the fibers. And fibers also, depending on you are using continuous fibers, they are short fibers. So we have a lot of technology, because therefore I am trying to restrict on just going through the rendezvous, because I'm just giving you just small touches. I mean, if you see, I mean, as a new student, as a new researcher, you see, I mean, you just start in injection molding, then you will find a vast field, So what we say in usually, if you know more, I mean, if you learn more, then you understand how little you know. So that is what you have to think, that in every field you have very big possibilities to do that. I will come back again, because we have to think about what is more practical, implementable for from this Indian point of view. Then we have filament winding, that is pultrusion, that is what we are working with the continuous fibers. And then for example, aeroplanes, there we have very high performance. So we don't work with short fibers. So there all the production methods that you use, that is uses continuous fibers. So just to give an idea about how much plastics we are using and how the growth is. So if we can look into the plastic production, and this is from 2017 that I have the figure, and you can see that in 1950 we used just 1.5 million ton, and now it has grown up to 348 million tons. So if we look into this compound annual growth rate between 1950 to 2017, so it's a plus 8.5%. So you can understand it's a very big growth. And if we look into the just global plastic production in 2017 compared to 2016, so it has increased by 3.8%. So in Europe in 2017 we produced about 64 million tons of plastics, and where Germany, because Germany is a big country, so they produced 20 million tons. So you can understand, I mean, these are figures. I mean, I'm not going into the, I don't know if million tons say something, because you use different type of, units, crores and all that, but I mean, you can figure it out. But I mean, this just gives you an idea what amount of material we are talking about. So if we come back again, so I think you can agree with me after, without going into the details, that we have a fantastic world of materials, because I mean that gives you fantastic opportunities to, get into whatever you do. If you do in a good way, so you have possibilities. So that is what we have to exploit. So if we look into what we call that, polymer technology, that is applied organic chemistry. Because as I mentioned, that we have to unite different units together. We want to unite them in a different way. So that means we have different type of polymerization process, and that we say chain polymerization, ionic polymerization, condensation polymerization. So that means we can control these type of polymerization and also gives you possibilities to make research